All right, I'm honored to introduce our next guest, Don Kirkby. Don's user page on GitHub is dubbed Playful Programming. He's a birthday cake enthusiast and a puzzler, a really good combination, by the way. His live coding page on GitHub introduces a process by which his plugin continuously runs Python code while you edit it. And his YouTube channel includes some really cool Lego assemblies with his daughter. Please join me in welcoming Don Kirkby for his talk entitled Visual Unit Tests and Live Coding.
Thank you. When I saw the schedule and saw that I was going to be at the near the end of the day on Sunday, I was a little worried that people might be nodding off. But thanks to Hervé's high energy talk, I think we're in a good place. So I am going to try and continue that energy level by talking about some tools that I'm really excited about building, and let's get into it. So I'm Don Kirkby. That's my favorite puzzle up there, and why am I here today? It's a follow-up to a talk that I gave at the 2023 PyCascades about live coding. And so I'm going to talk today about some unit testing tools for visual code, and they can be used on their own, but I think they really power up when you combine them with a live coding environment. So what am I talking about by visual code? Some examples, things like data visualization with matplotlib. This is a custom GUI that I built using PySide for an art project, puzzle project, where you're dividing a picture up into pieces that you're then going to assemble with the puzzle. So what am I aiming at? I'm looking for the kind of environment that you get with environments like a GUI builder. You know, you're dragging and dropping controls, fields, dropping them on the interface. Things like spreadsheet charts and graphs. The idea is that you get that, you have that intuitive interface of drag and drop, and you get that instant feedback so you can try something, tweak the settings, and see which version you like. So can we do that with Python code? So I'll start with a little example, start with the typical matplotlib workflow. So this is a toy example that I found. It shows up in a lot of machine learning tutorials where you've got some housing data, you've got a comma-separated values file, CSV file with housing data, and so it looks like this. You've got what was the price of the house when it sold, how big a house was it, and then a bunch of other attributes that I'm not going to look at today. So I'm just looking at how does the price relate to the size of the home. Whoops. Let's go here. Okay, so this is totally basic, reading in the file, then sorting it by area, and finally plotting the area and the prices just with the default matplotlib function of plot. So when I run it, I get a plot, not a useful plot. What is going on over here? That's a total mess. This doesn't look like anything useful. Okay, got to remember that when you read in data from a CSV, it's all text, right? So instead, I should convert the area to an integer and convert the price. And let's try it again. Okay, so now the axes look readable. I can see I've got my area along the bottom and my prices up here, but what's this weird diagonal line through the middle of my graph? That's really strange. So let's just plot the area and see if it's doing what I think it should. Okay, so that's obviously wrong. I had sorted the area, But notice it shows me all the numbers that start with a 1 first, and then the numbers that start with a 2 and a 3. I've sorted the numbers alphabetically. It was still text when I sorted it. So I converted the text to integers too late. So let's go in here, and instead of this simple just converting all the rows to a list, let's use a list comprehension and do the conversion at the same time. So I'm going to say row for row in reader. So that's the same as what I did with just a list, but instead of the rows as they came in, let's convert them into a dictionary of integers. So I've got the area is the int of row area, and then I want the, whoops, I need a comma. And the price, integer, row, price. All right, when we run that, okay, so now the areas look normal. They're actually sorted numerically. And let's go back and put the prices back in the plot. Okay, so it looks like what I expected the first time. But it's still not really useful, right? It's a very zigzaggy line. There's a lot of noise in there, so this is not a good candidate for a line graph. Let's try a scatter plot. So luckily, matplotlib is very helpful, and we just have to tell it, show me it with little dots. Okay, so now that's a little more useful. It's very crowded down here. There's another feature that matplotlib gives us where we can make each dot sort of semi-transparent. It's called alpha. So so that way if there's collisions, it's more obvious. So now when I run it, you can see that I've got, these are all single dots, and then when they're down here, they're overlapping, it's darker. Still, the color is maxed out, so let's try a slightly smaller alpha value. Okay, I think I went too far. Can't really see much there. Let's try 0.25. Okay, so now that's kind of what I want to see when I'm exploring a data set. Maybe the next step would be I'd add a linear regression line or something like that. That was a toy example of walking through a data set that's maybe new to you, and how do you use the tools to see what's in there and what would be a useful way to visualize it. So now I want to role play that again, but in a live coding environment. So I'm going to go back to what I started with. And turn on live coding. And so now I've got that same graph that I started with. Looks weird. Oh yeah, it's text, so let's convert them. And so now as I change the code, you can see now the x-axis makes sense. Let's make the change to the price. Okay, now I've got the axes make sense. There's this weird diagonal line. Let's explore by getting rid of the distraction of the prices. Oh, I've sorted it alphabetically. How's my acting? Is it good? Okay, so let's put in a list comprehension. And we're going to do row for row in reader. Okay, so that's exactly what I started with. Now let's convert it, each row to dictionary, and I'm saying area is int of area, and I remember the comma this time, price int of, row price, row area, okay. You guys are lousy pair programmers. Nobody shouted at me. Okay. Oops. There we go. All right, so now the areas make sense. Let's put the price back in. Okay, it's ziggy-zaggy. Let's put the dots in. Okay, so now it's starting to look like a scatter plot. Let's add the alpha. And each time I go along here, right, I'm getting that instant feedback, particularly at this last step where I'm kind of tuning a parameter. Oh, that's too light. I really like having the instant feedback of, like, sometimes you're twiddling that third decimal place, and it's nice to be able to instantly see the effect. Okay, so that was what coding looks like in a live coding environment. But what does that have to do with unit tests? Well, live coding is great when it gives immediate feedback, but in order to do that, it has to be fast, right? It can't be part of a long workflow where it takes 5 minutes to import a bunch of data and process it and get that final output data set that then you're going to display. You want to start with just run the display part. And what else has to be small, fast, and isolated? Unit tests. So is there a nice synergy between unit tests and live coding, and particularly with visual code? So in case there are anybody who hasn't written many unit tests yet, I thought I would take a step back and do a 5-minute lightning talk on unit tests in the middle of this. If you want more detail, here's a couple of resources, an essay that I wrote a while ago, and a nice in-depth exploration of PyTest, if you want to get more info on where to go with your unit testing exploration. Okay, so the core idea of test-driven development is the counterintuitive idea that you call the code from a test before you write the code. So even if you haven't written the math util file yet, in this example, we're going to implement a little toy function called power that raises one power to the power of another. So we're going to import that imaginary function, and then for every number from 1 to 9, we're going to go through and test that when you call power with that number and the power of 2, you get back the number times itself. So when you run that, it says module not found. You didn't write that file yet. But that's okay. The purpose of doing that was to think about how you want to call the code, particularly when your code is more complicated than this toy example. You can often discard a few bad design ideas before you write them, which saves you time. Okay, so now you write just enough code to make that test pass. So I'm going to create a new file called mathUtil. I write the power function, and I don't do any error handling. I don't do anything exotic. I just do what's the happy path that I tested in that test I already wrote. So I start with the number 1, and then I go through as many times as the exponent, and I multiply that base number. So if I passed in 3, I would start with 1 times 3 times 3 and return 9. So now when I run the test, it passes. So after a minor celebration, you think, okay, what's the next scenario that you need to handle? Well, in this example, we've decided that negative exponents are scary. I don't like division. And the users, most importantly, they don't need it yet. So instead of implementing division, we're just going to raise a value error. And this test checks using the PyTest raises function to say that when I call this, everything within this with block, when I run that, something is going to raise a value error. And the code that we had doesn't do that. If you pass in -1, it's just going to skip that for loop and return 1. So when I run it, I get failed, did not raise the expected exception. Okay, so we've now got a failing test. We go and we add a guard clause at the top. If the exponent is less than 0, we raise a value error. This code we didn't change at all, right? The error handling didn't affect this, so we leave it alone. And then we go back and we run the test, it passes. So we've gone from, we write the test, it fails, gives you a red message. Then you write just enough code to make it pass. You get a green message. And what do we do after that? Think over your life choices. Can this code be any simpler, more elegant? Did I do something that, now that I've got that safety net of the tests, can I stretch myself a little bit and come up with a more elegant design? Now, in this example, turns out that you don't have to go through a for loop calculating the number every time. Python, one of the batteries that Python includes is an exponent function, and so I can just use that. But I'm still going to keep my error handling. Okay, so that was the 5-minute lightning talk on unit tests, and again, there's where to go if you want to dive in more. So now, can we put those two things together? Live coding needs to be responsive, and unit tests are small and fast. Are they a perfect pair? They have sometimes, but there's some problems as well that I'll talk about at the end. So, what can I find out there as inspiration for unit tests in Visual Code? Two really popular Python packages that deal with graphics are Pillow for reading in graphics files, some basic drawing tools, and then Matplotlib that I was playing with earlier. So Pillow does include a function called AssertImageSimilar for comparing two images. Bad news is it's not included in the library. It's in their development environment, but they don't ship it with the library, so not for you. Matplotlib, however, does come with some tools. Here's one that I found called Check Figures Equal, and the idea there is a figure is the basic graph in Matplotlib, and when you use this decorator around a test case, it passes in two figures. One is the figure that you're going to do the test on, and one is a reference figure, so it's what you're comparing to. So here's a trivial example where I've got some test data, right, just a list of 3 numbers. I get the axis off the figure because that's what you actually plot on. And then I use that same basic plot function that I used before, just plot the data. So this is my expectation. This is what I think my code will do. And now when I go and write the code, unfortunately I'm a little bit clumsy, and I introduced a small bug by adding a small number to one of the numbers in the list. And so when you run that test, it's going to fail because the two graphs aren't quite the same. But it's more helpful than just saying, you failed. It'll actually give you 3 images. So the first two of them look very much like this, right? That's the 3 numbers that you plotted. And if that's all it gave you, it might be hard to tell that there was a tiny little difference between these. But it also gives you a third image, which is the difference with the differences highlighted. So I'm going to zoom in on that. And you can see that it's highlighting that this is the point that's different, right? Imagine that there were a few more points on that graph. It might be hard to tell which one was different, so this zooms in on the difference. All right, so that's what I found for inspiration. And so now let's look at a project that I've been working on and how I've used the visual unit testing tools in there. So as mentioned, I'm a puzzle enthusiast, including designing some of my own. And the idea for this one is that I construct a crossword puzzle. Here's a tiny example. And then I break it apart into blocks of 4 letters in tetromino or Tetris shapes. You shuffle those up, and then you give the solver standard crossword puzzle clues. And so, maybe 3 across might be working seats. And so you get the first couple of letters, DE, and then you have to figure out, oh, it's desks. Well, then do I have an S or an SKS somewhere? So these probably go back together. So how can I take that idea and turn it into some code that'll actually produce PDFs that people could download and print out, or I can send off to an online server where they'll actually print this out on cardstock and cut it out with lasers. And if you want to try those later, come and see me, or I'll be at the sprints on Monday. You can try those out. So what does the code look like? Well, as part of the live coding environment, I also published it as a standalone library that includes some testing tools like this live image differ class. And it's very similar to what you saw with the matplotlib. So here's an example. So I'm taking one of those squares with a letter on it, a letter and a number, and if I run it, and then switch over to live coding mode, you can see that it's drawing the what the actual code is drawing and what I expect it to do, right? It's a square, a letter, and a number. So in the code, we've got this PixMap differ, and it's creating two painters, which is what we use in the PySide environment for doing drawing, an actual and an expected. And if we look at the expected, you can see here are the things that I'm doing to make this expected image. So I'm setting the font size and then drawing the number 12, changing the font to a bigger font, and drawing the letter W, okay? And so if I get rid of that, you'll see the number disappear from the expected image. It highlights that difference. And so let's say that I want to change the, if you look very closely, you can see that this 12 is slightly closer to the top of the square than it is to the letter. So it would really make me sleep better at night if those were balanced. Okay, so now it's got the same gap at the top and the bottom, but now I've got a difference between my expected image and the actual image. So let's go into the draw function, turn on live coding again, and so now if I change the code, hopefully I can get it to match what the expected image looks like. Okay, so maybe I haven't looked at this code for a while. What are all the features in here? Oh, it's drawing the background color, because in some situations I want it with different colors. And then, oh yeah, there's a number and a suit sometimes for some of the bigger puzzles. Here's where it draws the number. Okay, and what's it doing? Oh, okay, I see that there's this number shift, and it's shifting it in the x coordinate, but it's using 0 as the y coordinate. So I want to introduce a vertical shift as well as the horizontal shift. So I'm going to change this to horizontal, and then I'm going to create another one, call it vertical. Okay, and then go in here and add the vertical. Okay, oh, that messed up the letter as well. I forgot that I have to undo the shift after drawing the number. Okay, so the letter's back. So now I have shifted it, but I've shifted it too much. So what happens if I divide it by a bigger number? Okay, we're getting closer. Closer. No change. There we go. Okay, so that's matched. So I made the change in the expected image using those concrete values, and then I went into the real code that's got all kinds of calculations for lots of different scenarios, and made that code match, made it work for the scenario in the test. And when I'm doing this, I'm constantly going back and forth between the concrete examples in the unit tests and the more abstract calculated values in the real code. Okay, so this is sort of the bottom, simplest layer of a single square with a letter and a number. So let's go up a level. So now I run this test. And so remember, I grouped those letters into blocks of 4. And let's say in this example, you can see that what I've done here is, again, I've got the expected, and so I'm drawing each of those 4 squares on the expected painter, and then I'm adding lines. So you see, I set the border color to blue and the interior divider color to magenta. And so now I'm drawing 3 magenta lines. That's these, sorry, down in the expected. These are these 3 internal ones, and then a bunch of blue ones around the outside. So let's say that I want to make the change to, instead of the dividers going all the way to the edge, I want to leave a little gap because I think that would look more elegant. So I go in here and I add a gap, right? It just starts a little bit farther, and you can see it's now there's a gap here, and it's highlighted the difference for me. And particularly for small differences, it adds this extra little circle around there to help you find it when there's like a 1 pixel difference and you can't tell what it is. All right, so let's make a balancing gap on the other side. And we'll do the same thing for the vertical ones. Right, and so I'm going through this concrete example and just twiddling the numbers until it looks the way I want it to look. Okay, so now we shift into the actual code, follow that link, turn on the live coding. And okay, now I've got the difference. And in this case, it's a little more complicated than the last code, right? I'm rounding the x coordinate minus x0 divided by the size. I can't remember what this was doing. I wrote this 6 months ago. Okay, instead of looking at it in graphical mode, let's look at the sort of see inside my code live coding version. So that's now showing me what are the variable values, and when I've got a for loop, each column here is an iteration of the loop. Okay, so scaled positions, oh, I see, they're all 0, 1. So these are the sort of integral relative to positions to those 4 letters relative to the top left corner of the block, right? So this is 1 down from the top left, 1 to the right from the top left, 2 down, and right in the top left. Okay, so that's what it's drawing, or what it's calculating, and then we go through each square in the 4, and for each one we calculate, okay, the scaled x and y, those are the positions for the current square, and then we look at scaled y minus 1, that's above the current square. Is there another square above this one? If not, then I'm going to draw an outer boundary, an outer border. If there is one above me, then it's an interior divider, and it's the interior dividers that I want to tweak. So let's go back to graphical mode. Okay, and I'm looking at this and I see, oh, there's already a couple of flavors of this square. It can either be packed, like in this mode, or it can be on its own for when you're doing sort of the print and play version that people can download from the website. And it looks like the packed one already has a gap. So let's just copy that and put that down here and get rid of that one. Okay, so that's close, but notice that it's still highlighting a difference there. Turns out that I divided it by 4, and the example that I decided on now is that it should be 1/5. So let's tweak that. Okay, and maybe there's a reason that I wanted to have a different gap for the packed mode versus the other one. It's nice when you're your own user. You can be as finicky as you want. Okay, so now that matches, and let's do the same thing for the vertical gap. Okay, so now we're pretty close, and you see it's highlighting those differences. 5 and 4/5 instead of 3/4. Did I get that? Yes, okay. So now the test is passing again. All right, we're going to go one more level, and then we'll wrap up. So we've got, this is now a complete puzzle, although a very small example. So I've now got 3 blocks of 4 letters each, and let's say that I want this gap to be a little bit bigger so that it's easier to cut out when you print it out. So I can go in here and, okay, which of these is block 1 versus block 2 versus block 3? Well, I just comment that out and look down here. So that one disappeared, so that's block 1. So let's go, that one we want to go down, so the y needs to be a little bigger. Okay, that's what I want, a bigger gap. And then is block 2 the other one? Yes, that's the other one I want to move. So I go up here, block 2. I want the X to be a little bit bigger, so it's off to the right, and the same change on the Y. Okay, so now I've made the expected picture has a bigger gap than the actual picture. And you can see that it's highlighting the differences, and the blue is the actual, and the red is the expected. Okay, so now if I go follow the code, so this time we'll turn on live coding. This time we got a little bit luckier. I see there's a gap variable. Maybe that's helpful. So I want to make this a little bit bigger. It's divided by 2. I find it more intuitive when I want to increase the gap to use multiplication instead of division. I could divide by a smaller number, but let's say times 0.5. Okay, so that's unchanged. So let's go a little bigger because we want a bigger gap. Okay, getting closer. 0.7, close. You probably can't see it, but the blue is slightly above the red. If I go 0.8, now the blue is below the red. I went too far. So let's try between the two. There we go, we got a match. So now the gaps match what I wanted. And notice that as I'm working in this higher level, the individual blocks have that gap that I introduced, right? So when you change the unit tests for that mid-level object, you don't break all your tests for the high-level objects, because if we go back to the test, it's not, this test isn't all lines and dots and letters and numbers. It's using the lower level blocks, right? It's drawing on expected with those blocks, and then adding the extra logic that you want. So in this case, it was just calculating or showing what size gap you want. So your lower level changes don't break your higher level tests. Okay, so let's go back here. So those are fun tools to play with. What could possibly go wrong? Well, long tests are going to kill your live coding environment, right? If you have to wait 30 seconds or 5 minutes, you're not going to get that feedback. Brittle tests. Visual tests, graphical tests are notoriously brittle, right? You make some change, and then suddenly all your tests are broken. Text and fonts, don't get me started. When I write tests and they work on my machine, and then I push to GitHub and it runs the tests on GitHub Actions, suddenly they've got different fonts. And then my tests break. Not good. When you're tweaking those numerical values in the concrete test case, sometimes just to get exactly that layout you want, you're going down to 5 decimal places. That just looks weird in your test. Like, where did that magic number come from? Okay, so what can we do to reduce some of that friction? Because at least in my experience, the excitement and exploration and playful interaction with the code is great, but it really sours when your tests all break. So how can we reduce the friction while still getting the fun part? So you saw how I used building blocks in those tests, right? I didn't draw every line and dot and number on the high-level tests. I used the lower-level classes to build up the higher-level image. Text, you can reduce the likelihood of problems by having another building block which is just for drawing text. And often it's a case of giving up on some of the flexibility of your canvas and just always drawing your text the same way. And so that way the tests are consistent. Anti-aliasing is a real irritant for this kind of test, because some implementations are actually using random numbers, and that's not good for unit tests. So in some cases, I've disabled anti-aliasing just for the test mode, and then you put the anti-aliasing back on for the real code so that it looks pretty. If all else fails, you can introduce a tolerance. That's something that the matplotlib uses. So if you can't make the images match exactly, just put in, say, as long as it's within this tolerance, it's good enough. Or you can blur the image so that some of that randomization of the anti-aliasing, maybe, it just washes out. And as long as you don't blur it so much that you can't tell when you've got actual bugs, that can be a good way to make your tests more tolerant. And finally, when you're drawing things on the canvas, you probably don't need all those 7 decimal places. If you do have those 7 decimal places, it'll make it slightly different from your test. So you, instead, just round the coordinates in your actual code, and then you can use those same whole numbers in your test. All right, so hopefully that was interesting, and I'd like to thank Brett Victor, whose talk was the original inspiration for the live coding environment that I built. The JetBrains team has provided me with licenses. They support open source projects with free licenses for their products. And thanks to the sprinters from last time that PyCascades was here in town, because we had a good time and got some features into the project. My employer puts food on my table and gives me a steady supply of interesting puzzles to solve, and my patient family for putting up with all the time I spend on these computer projects. If any of that sounds interesting, the puzzles, board games, or coding tools, you can find it all there on my webpage. Thank you.